the initial pressure of volume V1 of a fixed mass of gas P1, the gas expands at a constant temperature until it has reached the volume of V2 and the pressure of P2. All right, so the gas expands with the constant temperature and it reaches to the pressure P2 and volume V2. So initially, let's suppose this is the situation, and we have the gas at temperature T1 initially, then it expands. So of course, it's going to take the higher volume when it expands. So this will be again T1, but the pressure P2 and V2 are different from P1 and V1. Now, the concept is when the gas expands with the same temperature, its volume, its volume is of course increasing because that's why it's expanding, but its pressure will be decreasing. Okay, the pressure will drop, of course. Why? Because the pressure is how often the particles are colliding with the walls of the container. So they are now more expanded. So the space between each particle is more than before expanding, right? So the pressure will drop, right? So that's the concept. But let's see what options do we got. So which statement about the pressure and volume of the gas is not correct? Okay, so we need to find which statement is not correct about the pressure and volume. So pressure is measured in Newton per meter cube. So force, so pressure, the formula for pressure is pressure equals force per unit area. All right, and force is in newtons and area is in meters square. Yeah, we got the first one right, as this is the incorrect statement. This is an incorrect statement, right? Because the pressure is Newton per meter square, right? So yeah, the pressure is multiplied by the volume as a constant. Yeah, that's true. Pressure is directly proportional to 1 over volume. Yeah, that's true. And the ratio, yeah. So option A is the incorrect statement.